The Physics of Sound and Music doc with a review of Chapter T, Audiology. And once again, for these letter reviews, I'm going to go to the Foundational Physics, the chapter, and get you the foundation. And then here in the extra credit parts, you see overlap with the paranotes. Your paranotes always your best guide in studying for the examination. If you go to downloads here and go to the paranotes, and here we're going to paranotes T, the audiogram, you'll see the best way to focus on the material for the exam. But to give you a foundation of your basics, I'm going to go to the foundational physics for audiology and talk about this. So for audiology, the study of hearing loss, audiograms, we hear within the range from 0 to the dangerous region here of above 80 decibels up to 140 decibels. And the outer and middle ear, when these have problems, you tend that you have problems with all the frequencies. Then frequencies here from 20 to 20,000, that's detected in the inner ear, and we have inner ear problems. You have selective problems with different frequencies. So here is the audiogram. We have about 10 or so graphs in our course. Know always what is along the horizontal and the vertical for those graphs when you study for your comprehensive final. Here we have the frequencies arranged by doubling. They start at 125, double, 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 double. And this range is chosen because most of speech goes from 250 to 4,000. And here are your thresholds. It's bad to have a rating down here because that means that you didn't hear that frequency until we blasted you with 80 decibels and put a little mark down there. So here, the normal audiogram is up here around 0. Notice that you can have negative values. A person hears a half a pin drop or a fraction of a pin drop better than normal. Here we have a slight loss, mild loss, moderate loss. This would be kind of like having 20/30 vision or 20/40 vision, this kind of thing. And then down in here, 20/100. So this is your general designations for hearing loss, slight hearing loss. And here we have normal perception and hearing loss of 30 decibels. That means 30 is your barely perceptible sound, which is a whisper for the normal person. But see, you're not going to hear anything less than that, and you're going to hear the drop of a pin type of a sound, a sort of cushion. That's your whisper is going to sound like that. You're barely going to be able to hear that. So you do a shift then. See what's normal for a person in conversation at 60 decibels. Since you have a 30 decibel impairment, you hear that as a whisper. So you have trouble. So distractions in a restaurant, you're not going to be able to hear conversation easily. Well, we go on here to show the audiogram for Beethoven in his 30s. He has a uniform across the board hearing loss for all the frequencies, and that's typical of middle ear problems, which could be solved today fairly easily with drugs or with an operation. Beethoven would not be suffering if Beethoven lived today. Here's the audiogram of a rock musician. Notice we have a circle and an X for one ear and the other ear. You don't need to remember which is which. Just that there's two, one for each ear, and the rock musician tends to lose the high pitches. Remember that the high pitches are detected first in terms of position along the basilar membrane. They're closer to the oval window, and we're more sensitive to high pitches. And the combination of that, so if you pound away with the high frequencies, you have a hearing loss typically starting up in the high frequency range. And also, for example, with the Lars Ulrich in Metallica, he's hitting the cymbals, pss, 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 lots of high frequencies in there, and he suffers a hearing loss. Well, here is the spectrum analyzer where you have your frequencies along the horizontal and how much of each one. And as you talk or do things, you get these bars, this bar graph. And for a hearing loss, that is typical for the rock musician, you start to lose up in here. You can't hear those frequencies. Here is an audiogram of acoustic traumatic notch. Let's go ahead and get that up there for you to see. And there it is. Where if a gun goes off, an explosion, suddenly this is the kind of audiogram you tend to get for that. Destroying hair cilia, and then you get tinnitus. You get to hear the frequencies in there, which is sort of a double punishment, that when you have a hearing loss, you often hear the ringing in the ears. So that covers the foundational physics for a chapter on the audiograms.